Welcome to the deep dive. Today, we're not looking light years away. We're focusing on something much, much closer to home, something that's really testing us, our awareness, our technology.
That's right. We often see space as this vast, quiet backdrop, but it's actually incredibly dynamic, always changing. And sometimes that change involves potential challenges for us here.
Challenges like a cosmic visitor,
Yeah,
an uninvited guest.
exactly. We're talking about an asteroid heading our way. And just for context, scientists figure a really big impact, one that could cause, widespread problems that might happen roughly every 1,000 years or so.
So not if, but when.
Pretty much.
Okay, so our mission for this deep dive, let's unpack the story of one very specific object that's got scientists really buzzing.
Yeah.
We'll look at what it means for Earth, and maybe more importantly, what we're actually doing about it. It's this mix of like ancient myth and super modern science.
It really is fascinating.
So let's name our guest. It's an asteroid called Apophis. And that name,
Yeah.
well, it's pretty loaded, right?
It is. It's from the ancient Egyptian god of chaos. The giant serpent trying to swallow the sun.
Yeah, not exactly comforting. And this thing isn't small, is it?
No, definitely not. We're talking about a space rock about 400 meters wide.
400 meters. Can you, put that in perspective?
Sure. Think maybe 4 football fields lined up. Or if you tipped the Empire State Building on its side, it'd be even taller than that. It's a substantial object.
Wow, okay. And you said it's heading our way. It has a date with Earth.
That's the term, yes. It's on a trajectory that brings it very close.
So why all the fuss about this one asteroid? I mean, you track thousands, right? Near-Earth objects, NEOs.
We do, thousands every year. Most are tiny or pass by really far away, but Apophis, well, when it was first found back in 2004, the initial calculations, they showed a surprisingly high chance of impact later on.
Ah, okay. That would get attention.
It absolutely did, immediately. So understanding these kinds of potential threats is, well, it's vital for our future. Apophis isn't just another number. It's become this major case study for planetary defense.
Right. So when is this first date, this close encounter?
Okay, mark your calendars. Friday, April 13th, 2029.
Friday the 13th, seriously.
Seriously, the irony isn't lost on anyone.
And how close are we talking?
Extraordinarily close. It'll pass Earth at just 31,000 kilometers.
Wait, only 31,000? That sounds really close.
It is. That's only about 1/10 the distance to the moon.
Wow.
And get this, it'll actually fly below the orbit of many of our big communication satellites, the geostationary ones. They're usually around 36,000 kilometers up.
Below the satellites, that's incredible. Has anything this big ever come that close before that we know of?
Not in recorded history, not that we've tracked. We think the last time something of this size got this close was maybe 1,300 years ago. Long before we had telescopes pointed up there looking for this stuff.
Okay, so 2029. It's going to be quite a spectacle. Will people actually be able to see it?
Yes, absolutely. That's one of the amazing things. On that night, people across large parts of Europe, Africa, and West Asia, they should be able to see it as a point of light moving across the sky.
Without a telescope?
Without a telescope. It'll look like a star maybe, moving relatively slowly, but definitely visibly moving over a few minutes. It's a unique chance to see a celestial neighbor up close.
But you said earlier this flyby. It's close, but it's not the real danger.
Right. It's incredibly close, a fantastic opportunity for science, but the 2029 pass itself isn't the impact threat. It's more like, well, a prelude.
A prelude to what exactly? That
Yeah.
sounds ominous.
Well, this is where it gets really interesting and maybe a bit concerning. It introduces this element of chance, what you might call a cosmic gamble.
A gamble. How so?
It's all about Earth's gravity. As Apophis flies past us so closely in 2029, our planet's gravity is going to give it a significant tug. It'll bend its path, change its orbit.
Okay, that makes sense. Gravity affects things.
But how it bends depends exactly where it passes. And this is where we get to something called gravitational keyholes.
Gravitational keyholes, what are those?
Imagine tiny, very specific regions of space near Earth. Really small, maybe only about 600 meters across.
600 meters. That's tiny compared to the distances involved.
Exactly. Incredibly precise spots. Think of it like trying to thread a needle from millions of miles away.
Okay. So what happens with these keyholes?
Well, they're like little gravitational traps almost. If Apophis happens to pass through one of these very narrow keyholes during that 2029 flyby,
Uh-oh.
then Earth's gravity will bend its orbit in just the perfect way, like a carefully calculated cosmic slingshot.
Perfect for what?
perfect to put it on a direct collision course with Earth, returning 7 years later in 2036.
Wow. Okay. So passing through this tiny 600-meter window in 2029 means a potential impact in 2036.
That was the concern, yes. It really highlights how, small changes in these chaotic systems can have huge consequences down the line. A tiny difference in 2029 could mean the difference between a harmless pass and, well, something else in 2036.
So let's talk about this something else. If the gamble goes wrong, if it hits a keyhole and comes back in 2036, what would that impact actually look like? We hear asteroid impact and think extinction level event.
Right, and that's a really important distinction. Apophis is big, but it's not big enough to cause a global extinction like the one that wiped out the dinosaurs. Let's be clear about that.
Okay, that's somewhat reassuring.
But it would absolutely cause, as scientists put it, an unimaginable regional catastrophe.
Regional catastrophe. Can you break that down? What does regional mean in this context? How bad are we talking?
Regional could mean devastating an area the size of, say, a large state or even a small country. The energy released would be immense. Think tens of thousands of nuclear bombs going off at once.
Tens of thousands.
Yeah. The main damage would be the blast itself, the shock wave. Then you'd have seismic effects, earthquakes. If it hit water, huge tsunamis. Plus, all the dust and debris thrown into the atmosphere could cause regional climate shifts, affecting farming, supply chains.
And the economic cost.
Some estimates put in the direct economic damage alone at around $400 billion. And that's not even counting the human cost, the environmental disaster. It's a scenario we absolutely want to avoid.
Absolutely. So, knowing this, knowing about the keyholes and the 2036 risk,
Yeah.
are we just, crossing our fingers for 2029? Are we just waiting?
Oh, definitely not. No, the scientific community sees the 2029 flyby as a huge opportunity. A golden opportunity, actually.
Understood.
Because it's coming so close, we can study it like never before. We'll hit it with everything we've got. Powerful radar from places like Goldstone in California, space telescopes.
What are they trying to find out?
Everything. Its exact path, of course, but also how it spins, what it's made of, its internal structure. Is it solid or more like a rubble pile held together by gravity? All that information is critical if we ever needed to, intervene.
So there are actual plans. We're not just observing.
Absolutely. NASA, ESA, other space agencies, international groups, they're actively working on and refining options. This isn't passive observation, it's active preparation.
What kind of options are we talking about? Like in the movies, sending Bruce Willis up there?
Well, maybe not quite like that. Lifting it up is generally seen as a bad idea. You might just create lots of smaller, harder to track pieces still heading our way.
Right. Okay. So what's the main plan?
The most promising approach, and one we've actually tested, is called a kinetic impactor.
Kinetic impactor. Sounds cool. What is it?
Basically, you launch a spacecraft unmanned, of course, and you deliberately crash it into the asteroid at very high speed.
Crash into it. To do what?
Not to destroy it, but just to nudge it. The sheer momentum transfer from the impact, even from a smaller spacecraft hitting a big asteroid, can slightly change its speed and therefore its trajectory.
Just a little nudge.
Exactly, a very small push. But over the vast distances and the years leading up to a potential impact, that tiny nudge is enough to make it miss Earth entirely, or in this case, miss that critical keyhole.
And you said we've tested this.
We have. NASA's DART mission back in 2022. It successfully slammed into a small asteroid moonlet called Dimorphos and measurably changed its orbit. It proved the concept works.
That's incredible. So how much of a nudge would Apophis need before 2029 to avoid a keyhole?
Get this, the calculations show that changing its path by just 800 meters. 800 meters before the 2029 flyby would be enough to make it miss the dangerous keyholes.
Only 800 meters. That sounds tiny. But I guess hitting something moving that fast, that far away.
It's an immense challenge, like hitting a specific bullet with another bullet halfway across the solar system. The precision required is just staggering.
Yeah, no kidding.
But it really highlights something historically significant, doesn't it?
What's that?
For all of human history, we've basically just been passengers on this planet, vulnerable to whatever the cosmos threw at us. Impacts were seen as, acts of God, fate, unavoidable.
Right.
This is the first time, first time, we've identified a specific potential threat like this so far in advance, and we actually have the technology, the understanding to potentially do something about it.
We can actually fight back, in a way.
Or perhaps, better put, we can proactively manage the risk. So Apophis, It's more than just a warning. It's really a profound test
The test of what?
of our wisdom, I think. Our technology, yes, but also our ability to cooperate globally, to share data, pool resources, make decisions together for the good of the planet. It forces us to think beyond borders.
That's a powerful thought. What does this whole situation teach us about ourselves, about our responsibility?
It tells us we're entering a new era, maybe, where we're not just inhabitants, but potentially becoming stewards of our planet on a cosmic scale. It's a huge responsibility, but also shows incredible capability.
So, summing this up, this chaotic god, Apophis, is heading our way. But unlike in the ancient myths, humanity isn't just watching helplessly.
Not at all. We're watching, yes, but we're also preparing, planning, we're readying ourselves, using science and ingenuity. It's a demonstration of planetary defense in action.
It really changes how you think about our place in the universe.
It should. So maybe the next time you look up the night sky, yes, feel that sense of awe, that respect for the power out there, but also maybe feel a bit of confidence in human ingenuity, in our growing ability to understand and even interact with that cosmos to protect our home.
It's not just about dodging a bullet then.
No, I think it's about recognizing this moment in our development as a species. We're learning to manage our environment on an entirely new level. Makes you wonder, doesn't it? What other cosmic challenges might we be capable of meeting in the future?
A question to ponder. Thanks for this deep dive.
My pleasure. It's certainly a topic worth thinking about.